Hi, students and friends. This is your host and teacher, Sayyid Ayaz Haider, and you are watching Learn and Teach by Sir Ayaz. So, I was doing the paper, past papers, and for this video, I have selected 5070, May June 2023, and the variant is 21. This is paper 2, which is theory. You have to answer on the question paper. You are allowed to use calculator. The total mark for this paper is 80 and the time is 1 hour 45 minutes. So let's start the paper. Periodic table is printed in the question paper. So you can use it for questions. Question number 1. Choose from the following oxides to answer the questions. Each oxide may be used once, more than once, or not at all. State which oxide A is a solid made during the thermal decomposition of limestone in the blast furnace. In the blast furnace, decomposition of CaCO3 results in the formation of two products. This is a reaction. We'll get CaO plus CO2. So the solid product in this reaction is CaO. Here it's CaO, so you write CaO for this question. Part B. State which oxide reacts with both acids and alkalis. They are talking about amphoteric oxide. So if you look at the choices, one of the oxide is amphoteric and that is Al2O3. Part C has a giant covalent structure. Now they are saying giant covalent structure, not only giant structure. So giant covalent structure, we have only one giant covalent structure in these choices. We have SiO2. So you write SiO2. Number D has an ion with an oxidation number of +2. So if you look at these, here we have metal oxide 1, metal oxide number 2, metal oxide number 3, metal oxide number 4. I am writing the charges on these. In Al2O3, aluminium belongs to group 3. Here you can see it's aluminium, it's in group 3. So it must carry +3 charge. So I will write aluminium +3. What about CaO? CaO, where is calcium? Calcium is in group 2 and group 2 carries +2 charge. So Ca will be carrying +2 charge. So CaO must be the answer for this question. Charge or oxidation number have same meaning. Oxidation number is a charge on atom, ion, molecule. So here we have CaO as the answer. Number E, turns white anhydrous copper to sulfate blue. Now they are definitely talking about water. Here it is. Water turns anhydrous copper to sulfate to blue. F is made during the fermentation of aqueous glucose to make ethanol. Two products are produced during the fermentation of glucose. Will get ethanol and carbon dioxide. Here it is, carbon dioxide. So we will write CO2. Let's move to next question. Question 2. Group 1 includes the elements lithium, sodium, and potassium. A. State 2 physical properties of lithium. Now, group 1 metals, here we have group 1 metals. This is group 1. We have lithium, sodium, potassium. They have some typical properties like they are soft, they have low density, low melting point, they are shiny, and other typical properties being a metal is that they are good conductors of heat and electricity, they are ductile, malleable. So you can write any two from these. So any two from, write soft, low density, low melting point, conducts heat, or you can even write thermal conductor, conducts electricity, you can write shiny, malleable, ductile, any two of these. Part B, potassium reacts with cold water. The ionic equation for the reaction is shown. 2K S means solid state, 2H2L, L means liquid state, gives 2K plus aqueous. This is one of the ion produced in water. Aqua means, AQ means water. Plus 2OH minus aqueous plus H2 gas. Number 1, state in terms of electrons why potassium is a reducing agent in this reaction. You see, in this reaction, potassium being a metal, it is losing electron because there is no charge on the potassium on the left hand side, that is the reactant side, and on the right hand side you can see it scanning +1 charge. Plus means +1, which means it has lost electrons. So you will write potassium loses electrons or loses electron. Number 2, state the oxidation number of hydrogen in H2. In H2 we don't see any charge, which means there is 0 on it. So simply the answer is 0 in this case. Number 3, describe what is observed during this reaction. Now they are asking about the observation in this reaction. So you can write any 3 from these because this question is carrying 3 marks. So you'll write any 3, like potassium floats on water. Potassium floats on water. You can write potassium melts, or we see bubbles or effervescence. Effervescences, or potassium forms a colorless solution. Or the piece, potassium piece gets smaller. Or you can write mention flame color. You know potassium burns with lilac flame, so you can write lilac flame here. So you can choose any 3 of these. A sample of sodium chloride is tested using a flame test. State the color of the flame seen in this test. Now they are asking about the test of the sodium in this case, which will be either yellow or orange. Question number 3. This question is about the preparation of salts. A, zinc chloride is a soluble salt. It is prepared by the reaction of an insoluble base with a dilute acid. The equation for this reaction is shown. Here is the reaction. ZnOS plus 2HCl aqueous gives ZnCl2 aqueous plus H2O liquid. a sample of 3.50 gram of zinc oxide is added to 50 centimeter cube of 1.2 mole per dm cube hydrochloric acid. Number 1, show by calculation that the zinc oxide is in excess. Now the easiest way of doing this question is start converting the reactants into moles, as we have the information of reacting moles from the reaction equation. So first of all, I am going to calculate the MR of zinc oxide in order to convert the grams of zinc oxide into moles. So zinc oxide, the formula of zinc oxide is ZnO. So MR for ZnO will be 1 atom of zinc. So 1 multiplied by, where is zinc? Here is zinc. Here is the mass 65. What about oxygen? Here is oxygen. The mass is 16. 65 plus 16. As we have only 1 atom of both of these elements. So we have 65 plus 16 and it gives 81. For your convenience, I am showing the calculation. 65 plus 16. You see the answer is 81. Now, in order to calculate the number of moles, you know the formula, number of moles is equal to mass, which is 3.50 divided by MR, which is 81 here. So 3.5 divided by 81, 0.043 moles. Now, for hydrochloric acid, the volume and concentration of hydrochloric acid is provided, so no need to calculate the MR of hydrochloric acid. We can calculate the moles of hydrochloric acid using this data. So according to this data, you can write 1000 centimeter cube, because 1 dm cube is equal to 1000 centimeter cube. 1000 centimeter cube contains 1.20 moles. Therefore, 50 centimeter cube contains X moles of HCl. So what you will do, you will multiply 50 centimeter cube by 1.2 and X will be multiplied by 1000. So equation becomes 1000 X is equal to 1.20 into 50, or X is equal to 1.20 multiplied by 50 divided by 1000. 1.2 multiplied by 50 divided by 1000. 0.06 moles of HCl. Now we can easily compare these moles according to the reaction equation. According to reaction, here we have ZnO and we have HCl. 1 mole reacts with 2 moles of HCl. Therefore, 0.043 moles of ZnO reacts with X moles of HCl. The answer will be X is equal to 2 multiplied by 0.043, 2 multiplied by 0.043, and we get 0.086 moles of HCl. Now compare these moles with the moles we have obtained. This mole is higher. This moles is higher and these moles are lower, which means we need higher moles of HCl. So HCl must be the limiting reactant in this case. HCl needs 0.086 moles instead of 0.06 moles. Hence, HCl limiting and ZNO is in excess, which is what they have asked in the question. Number 2, state why it is important to use an excess of zinc oxide in this preparation so that all the acid is used up or reacted. So that all the acid is used up. Number 3, suggest how the excess zinc oxide is removed from the reaction mixture to leave only aqueous zinc chloride. It's very simple. You can filter the solution, so you write filtration. Part B. Barium sulfate is an insoluble salt. It is prepared using a precipitation reaction. Name 2 aqueous solutions that react together to give a barium sulfate precipitate. So we have to start with these two any soluble salt of barium, like barium nitrate or barium chloride. Both of these are soluble, or barium chloride. Now you will react soluble sulfate of any metals, like you have sodium sulfate or magnesium sulfate, or you can even take potassium sulfate for this purpose. Next part C. Sodium nitrate is a soluble salt. It is prepared by the reaction of an acid and an alkali. Name the acid and the alkali used. Now we have sodium nitrate. Nitrate must be coming from the acid nitric acid, which is NO3. So acid will be nitric acid here. For sodium, you can take sodium hydroxide. Alkali will be sodium hydroxide here. Number 2, name the experimental technique used to make neutral aqueous sodium nitrate. Simple titration. Next question. This question is about compounds that contain phosphorus. The formula for a phosphide ion can be written as P3-. Here they have shown the proton number and the nucleon number. Complete table 4.1 to show the number of particles in this phosphide ion. A particle, electron, neutron, and proton. The number of particles. Electrons, if you look at the charge on P, it's 3-, which means it has gained 3 electrons. Proton number is 15, which means you have to add 3 to this 15 and you will get 18. What about neutron? In order to get the number of neutrons, you will subtract 15 from 31. 31 minus 15, we will get 16. But about protons? Very easy. 15 must be the protons. State why the formula for a phosphide ion is P3- rather than P2- or P4-. It has complete electron shell. Complete electron shell. C. The formula for a calcium ion is Ca2+. Deduce the formula for a calcium phosphide. Now, the charge on calcium is given. It's Ca+2. And the charge on phosphide ion is also given. It's P3-. So you write -3. Ignore the charges. These are the subscripts. These subscripts will be exchanged when predicting the formula. Here we'll get 3 and 2. Ca3 P2. So the formula will be Ca3P2. Number D. Calcium phosphate Ca3PO4 whole twice is an ionic compound. Explain why calcium phosphate has a high melting point. You know, ionic compounds, they have giant structure. You can write giant ionic lattice or giant structure, and strong electrostatic force or strong force between the ions. Static force between the oppositely charged ions. Charged ions. Part E. Calculate the percentage by mass of phosphorus in calcium phosphate. Give your answer to two significant figures. So calcium phosphate, the formula for calcium phosphate is this Ca3PO4 whole twice. So first of all, we need to calculate the MR of this. So for MR, we have to multiply 3 by the mass number of calcium. Then we will multiply 2 by the mass number of phosphorus. Then we need to multiply 4 multiplied by 2 is 8. 8 by the mass number of oxygen. So let's see the mass number of calcium. Here's the calcium, mass number of calcium is 40. Phosphorus, here it is phosphorus, it's 31. Oxygen 16. 40, 31, 16. So 40, 31, 16. So 3 multiplied by 40, we will get 120, plus 2 multiplied by 31, we will get 62, plus 8 multiplied by 16, we will get 128. Adding up these, we will get 120 plus 62 plus 128 gives 310. Now they are asking the percentage by mass of phosphorus. So we have 62 as the mass of phosphorus here. So 62 multiplied by 100 divided by 310. So the answer will be 20%. Next question. Ammonium chloride decomposes when heated to make hydrogen chloride and ammonia. This reaction is reversible. The forward reaction absorbs thermal energy. NH4Cl(S) gives HCl gas plus NH3 gas. An equilibrium mixture is formed when the reversible reaction happens in a closed system. State what is meant by the term equilibrium. Include ideas about rate of reaction and the concentrations of the reactant and products in your answer. So in a reversible reaction, or for a reversible reaction, rate of forward reaction becomes equal to rate of backward reaction or reverse reaction. The concentration of reactants and products are no longer changing or remain constant. The concentrations of reactants and products do not change. Number 2, predict what happens to the position of equilibrium when the temperature is increased and the pressure remains constant? Explain your answer. They are asking prediction and explanation. So look at this reaction. You should know the forward reaction absorbs thermal energy, which means it's endothermic, which means it favors high temperature. So if you increase the temperature, equilibrium will shift to the product side. Shift to product or right hand side. What is the reason? Forward reaction is endothermic. Or you can write backward is exothermic, or backward reaction is exothermic. What else you can write? To decrease the temperature or to lower the temperature by absorbing heat. Next part. Predict what happens to the position of equilibrium when the pressure is increased and the temperature remains constant. Now they are asking on the effect on the position of equilibrium when the pressure is increased. For this, you should know the number of moles of gases. So if you increase the pressure, it will move to the side where there will be less number of moles. So you can see from this equation, for your convenience, I am writing it here. NH4Cl. We have NH4Cl solid, NH3 gas plus HCl gas. So if you see on the right hand side, you have 2 moles of gas. On left hand side, you have 0 moles gas. So definitely equilibrium will shift to the reactant side. Shift to reactant or left hand side. You can mention the number of moles of gases. Higher number of moles or volumes of gases on product side. Or you can even write less number of moles of gases on reactant side. Predict what happens to the rate of the backward reaction when the temperature is increased and the pressure remains constant. Now they are talking about the rate of reaction, not the equilibrium. So if you increase the temperature, rate increases. Why? Particles have more kinetic energy, or higher number of particles have energy equal or higher than the activation energy. You can even write greater number of collisions or greater number of collisions. Okay, number C, predict what happens to the rate of the backward reaction when the pressure is increased and the temperature remains constant. Explain your answer. Now, what happens to the rate of the backward reaction when pressure is increased the rate increases. Rate increases because you have uh, higher number of particles per unit, higher number of particles per unit volume. You have higher number of particles per unit volume, so you have frequent collision or frequent collisions taking place. So let's continue from question number 6. This question is about the energy changes that take place during chemical reactions. A. Methane reacts with chlorine to make chloromethane. The reaction is exothermic. CH4G plus Cl2G gives CH3Clg plus HClG. Draw on the axis provided in figure 6.1 the reaction pathway diagram for this reaction. Include labels for the axis, reactants, products, enthalpy change of reaction, delta H, and activation energy, EA. So here we have to include axis on this diagram. So on x-axis we have reaction pathway. So write reaction pathway here. You can even write time. And on the y-axis you have temperature or energy. If you're writing temperature, then we have to mention centigrade or energy. Energy, it's up to you if you write kilojoule. Now the reaction is exothermic. Remember, in exothermic, the product will be at the lower energy state than the reactants. The product will be at lower energy state than the reactants. So if we have reactant on the left hand side, this will be the product. What are the reactants? We have CH4 plus Cl2 gives CH3Cl plus HCl. So write CH3, CH4 plus Cl2, and on the product you will write CH3Cl plus HCl. Now I'm going to draw the energy hump for this exothermic reaction. This is the energy hump. And you know the activation energy, if it starts from the reactant, this axis reactant, and it will go up. We label it EA. The sign for EA is always positive, whether it's exothermic or endothermic. Now the energy change between these two sides, that is reactant and product side, we call it enthalpy change of reaction or delta H. This must be between reactant and product. This will be the enthalpy change, delta H, and sign is minus. Moving to part B. Hydrogen iodide decomposes to make hydrogen and iodine. This is a reaction. 2HI gives H bond H plus I bond I. Calculate the enthalpy change of this reaction. Use the bond energies in table 6.1. This is table 6.1. Here we have bonds H bond H, I bond I, H bond I, and these are the bond energies in kilojoule per mole. So we need to calculate the enthalpy change for this reaction. You know the formula for enthalpy change? I'm writing the reaction here. 2H bond I gives H bond H plus I bond I. You know that delta H will be energy change for reactants minus energy change for the products. So on the reactant side, what we have? We have 2 moles of HI. So 2 will be multiplied by 298. Minus, on the product side, we have 1 mole of H bond H. So we'll write 436 for H bond H plus 1 mole of I bond I, that is I2. So I'll write 151. So 2 multiplied by 298. We will get 596 minus 436 plus 151. Here we will get 6 plus 1, 7. 5 plus 3, we will get 8. 4 plus 1, we will get 5. 587. So 596 minus 587 plus 9. This will be the final answer for this question. Moving on to next part of this question. I'm writing the answer here. Question number 7. Methanol, propane 1-ol and propane 2-ol are alcohols. The displayed formula of methanol and propane 1-ol are shown in figure 7.1. Here we have methanol and propane 1-ol. This is figure 7.1. A. State the general formula of the homologous series of alcohols. This will be CnH2n plus 1 OH. B. Propane 1-ol and propane 2-ol have the same molecular formula but different structural formula. 1. State the name given to compounds that have the same molecular formula but different structural formula. You call it isomers or structural isomers. Structural isomers, or even you can write isomers for this. B part 2. Draw the structure formula for propane 2-ol. Now we will need to draw the structure formula. Remember, structure formula is also the condensed formula. In this, you don't need to show all the bonds. So propane 2-ol means OH must be at the second position, and propane means we have 3 carbon. First of all, you should know the formula for propanol. We have 3 carbons, so you'll write the value of N3 here, C3. H2 multiplied by 3 is 6, 6 plus 1, 7. H7 OH. This will be the final formula for propane 2-ol. Now I'm drawing the structure formula of this propane 2-ol. We must have H3C bond CH. Now you must have second OH at the second position. So I will write OH in the bracket here. Then we are left with CH3. It must be propane 2-ol. 1, 2, 3. This OH is on the second position. Alternatively, you can draw in this way also. H3C, single bond C, single bond H. Now I'm showing OH here. Now half part of this is shown as displayed formula and other half as structural form. So this will be the final structure formula for propane 2-ol. Both are correct. C. State why propane 1-ol is a saturated compound. It must be containing only carbon-carbon single bonds. So you write contains only carbon-carbon single bonds. D. State why propane 1-ol is not a hydrocarbon. Definitely it must be containing other element other than carbon and hydrogen. So you will write contains oxygen also. Contains oxygen also beside carbon and hydrogen. Number E, propane 1-ol reacts in the same way as ethanol. 1. Draw the displayed formula of the product of the reaction of propane 1-ol with acidified aqueous potassium manganate 7. Now, when you react ethanol with acidified aqueous potassium manganate 7, what will happen? It will oxidizes this into carboxylic acid. Alcohol plus, this is oxidation, and we'll get carboxylic acid. So ethanol gives ethanoic acid. Propanol gives propanoic acid. Propanol oxidation gives propanoic acid. Now they want you to draw the displayed formula of the product. We need to draw the formula of propanoic acid. First of all, you should know the molecular formula of propanoic acid. In propanoic acid, there will be 3 carbon atoms in all. So the general formula for carboxylic acid is CnH2n plus 1 COOH. The value N must be 2 here because we already have 1 carbon here. So you can't take 3 as the value of N. You have to take 2 instead of 3. So if you take 2, what you will get? You will get C2. H, 2 multiplied by 2 is 4, 4 plus 1 is 5, C2H5, COOH. This will be the formula of propanoic acid. Now it's a carboxylic acid, you must have C double bond OOH. So first of all, I am drawing the C double bond OOH. Now I am left with this part. This part I am left with. I am done with this part, COOH. Now I need to draw C2H5 in the displayed formula form. We have 2 carbon atoms. 1, 2. Show hydrogen. 2, 3, 4, 5. The formula C2H5 COOH is fulfilled here. So this will be the final displayed formula of the product obtained when propane 1-ol is oxidized or treated with acidified aqueous potassium manganate 7. Number 2, draw the displayed formula of the product of the reaction of propane 1-ol with ethanoic acid in the presence of a catalyst. Now this reaction is known as esterification. Esterification is the formation of ester when alcohols are reacted with carboxylic acids. So you are reacting propane 1-ol with ethanoic acid. This is propane 1-ol, propane dash 1 dash ol, and plus we have ethanoic acid. The other name for ester is alkyl alkanoate. Alkyl must be coming from this propane 1-ol. So we will get alkyl propyl from propane 1-ol. And from carboxylic acid, we will get alkanoate. It must be coming from the carboxylic acid. And in this case, it must be ethanoate. So propyl, there must be 3 carbon atoms. What you need to do? You simply need to exclude the OH. So this one is the propane 1-ol. 1, 2, 3. These all are hydrogen. And this one is OH. Now I am treating this with ethanoic acid, which will give alkanoate ion in this case. So I am drawing the displayed formula for alkanoate. H single bond O, C double bond O, CH3. Now in this reaction, there is a release of a molecule of water. So these will be removed as H2O. So final formula for propyl ethanoate will be this. You'll draw this in this way. Single bond O, single bond C, double bond O, CH3. This is propyl ethanoate. This one is propyl. This whole group is propyl ethanoate. This whole group is ethanoate. Part F. Methanol is a covalent substance. 1. Draw a dot and cross diagram to show the bonding in a molecule of methanol. Include only the outer shell electrons of each atom. First of all, you should know the formula for methanol. The general formula for methanol, it's an alcohol. So general formula for alcohol is CnH2n plus 1 OH. Here the value of N must be 1. It's math. So you write C1, H2 multiplied by 1 is 2, 2 plus 1 is 3, CH3OH. This will be the formula for methanol. Now I'm showing the key on the right hand side. We have carbon here, hydrogen here, oxygen here. It's up to you whether you want to take dot for carbon, hydrogen or oxygen. For oxygen, I'm taking blank dot. Now we have one carbon atom and 1, 2, 3 hydrogen atoms, and it's bonded to oxygen. Then oxygen is again bonded to hydrogen. Now I am removing bonds, and now I will show the outer shell electrons only. Outer shell electrons for each of these atoms. Let's start with the carbon. Carbon belongs to group 4. It must have 4 valence electrons. Hydrogen, it has 1 proton number. It must be having 1 valence electron. Oxygen, it belongs to group 6. It must have 6 valence electrons. 6, 4, 1. Coming back to the question. So for carbon, 1, 2, 3, 4. For each hydrogen atom, we need to show 1 valence electron. 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen, and 1 for this hydrogen. What about oxygen? I have just told you, it belongs to group 6. It must have 6 valence electron. 1, 2, 3, 4, 5, 6. Now you can make circles. And this is the circle for carbon. This one must be for the oxygen. So this will be the final dot and cross diagram for methanol. Number 1, state why methanol does not conduct electricity. Conduction of electricity must be related to the movable or free moving electrons. So you can simply write electrons cannot move or are immobile. Electrons cannot move or are immobile. Part G. Methanol is used as a solvent. State the meaning of the term solvent. Solvent is a liquid that dissolves a solute. A liquid that dissolves a solute. Next question, question number 8. This question is about electrolysis. A. The table shows some information about the electrolysis of the three different electrolytes using graphite electrodes. Complete table 8.1 with the names of the products at each electrode. First, you are having dilute aqueous potassium chloride. Potassium chloride means KCl, and it's a dilute solution. So the product obtained at anode must be oxygen, and at cathode it must be hydrogen. The reason is that both at anode and at cathode, the ions produced are K positive and Cl negative, beside OH negative and H positive. OH negative is below in the reactivity series as compared to Cl negative ion. For H positive ion, it's also below K positive ion in the reactivity series. Or there are other reasons. You can write hydrogen have high ease of discharge and low difficulty of discharge. Reverse statements will be true for both K positive and Cl negative ion. What about aqueous copper 2 sulfate? It's CuSO4. CuSO4 Cu plus ion is below hydrogen, so you must get copper at cathode. What about anode? We have graphite electrode, so you will get oxygen again here in this case. If you have copper electrode, then you will be getting copper at the dissolving of copper anode instead of this oxygen gas. Molten lead to iodide, it is PbI2. There aren't any H positive and OH negative ion because it is not aqueous solution. So you will get iodine at anode and lead at cathode. Part B. The electrolysis of aqueous copper 2 sulfate gives different products when copper electrodes are used instead of graphite electrodes. Describe the observations during the electrolysis with copper electrodes. You can write any two from these, like increase in mass of cathode or pink solid deposits. I will write increase in mass of cathode or pink solid deposits. At anode, there will be decrease in mass. Decrease in mass of anode. Or anode gets smaller and smaller. Smaller and smaller. You can even write color of the electrolyte remain or stays blue. Color of the electrolyte remains or stays blue. Part C. Magnesium is manufactured by the electrolysis of molten magnesium chloride. At the anode, chloride ions react to make chlorine molecules. Construct the ionic half equation for this electrode reaction. So this one is very easy. You simply have to show the oxidation reaction at anode. Chloride ion will be losing electrons to produce chlorine molecules. Cl negative gives Cl2 molecule plus electron. And if you balance the equation, there are two Cl2. We have Cl2 molecules, so you write 2 before Cl negative ion and 2 before electrons. This will be the final answer. Moving to question number 9. Oxides of nitrogen, such as nitrogen monoxide, NO, are atmospheric pollutants. The exhaust gas from a car engine contains 0.002% by volume of nitrogen monoxide. Calculate the number of molecules of nitrogen monoxide in 960 dm cube of exhaust gas at room temperature and pressure. 1 mole of any gas contains 6.02 into 10 raised to power 23 molecules. So first of all, we need to calculate the volume of nitrogen monoxide. And it's mentioned in the question, they are saying 0.02%, 0.00% by volume of nitrogen monoxide in 960 dm cube. So I will calculate 0.002%, 0.002 multiply by 960 divided by 100. It must be 0.0192 dm cube. 0.0192 dm cube. Volume of NO. Volume of NO. Now I will convert this volume of NO in moles. And you know 1 mole of any gas at room temperature and pressure occupies a volume of 24 dm cube. 1 mole occupies 24 dm cube. So X mole occupies 0.0192 dm cube. So equation will be 24x is equal to 0.0192 or x is equal to 0.0192 divided by 24. So what we will get? 0.0192 divided by 24. 0.0008 moles of NO. Now I need to convert this into molecules. So what you will do for molecules, number of molecules, multiply moles by the number of molecules, Avogadro number. So 0.0008 multiplied by 6.02 into 10 is to our 23. What we will get? We will get 0.0008 into 6.02. We will get 0.004816 into 10 is to the power 23. Now I will shift this decimal on the right hand side, 1, 2, 3. So it will become 4.816 multiplied by 10 is to the power 20. So 4.816 into 10 is to the power 20. This will be the final answer for this question. B. Nitrogen and oxygen react to make nitrogen monoxide inside a car engine. Construct the equation for this reaction. This is a reaction between nitrogen. Nitrogen exists as molecule form N2 plus oxygen, also in diatomic state O2. We will get NO. Balance the equation, we will get 2NO. This will be the balance equation. Number C. State 1 adverse effect of oxides of nitrogen as pollutants in the air. Now you can write any one from these. You have acid rain or breathing difficulties, or respiratory problems. Or you can even write photochemical smog, responsible for photochemical smog. Photochemical smog is produced a mixture of pollutant. It is found when nitrogen oxides react to sunlight. D. Describe how oxides of nitrogen formed in a car engine are removed by a catalytic converter. NO react with poisonous carbon monoxide to make N2. NO is reacted with CO to make N2. Part E. The rate of diffusion of nitrogen dioxide NO2 gas is less than that of nitrogen monoxide NO gas under the same conditions of temperature and pressure. 1. Explain why the rate of diffusion of NO2 gas is less than that of NO gas under the same conditions. Simply, you will relate it to the molecular mass of NO2 or MR of NO. So you write higher MR of NO2. Higher MR of NO2 or lower MR of NO. Number 2, the rate of diffusion of nitrogen monoxide decreases as the temperature decreases, such as why using ideas about kinetic particle theory, molecules have less kinetic energy. Molecules have less kinetic energy. Question number 10. PVC and polypropylene are polymers made by a reaction called addition polymerization. The diagram in figure 10.1 shows the structure of PVC. This is figure 10.1 and this is a diagram of PVC. Draw the structure of the monomer used to make PVC. Now I'm going to pick the repeat unit. You see, these are the repeat units. Repeat unit number 1, repeat unit number 2, repeat unit number 3, repeat number 4. These all are same. So I'm drawing the repeat unit here. Here we have repeat unit. Only one repeat unit is enough to draw the monomer. We are almost there. Now what I will do, I'm making the monomer, erase the bonds on the right and left hand side and make a double bond in the middle, that is between two carbon atoms. This will be the monomer used to make PVC. Part B. Polypropylene is a polymer used to make plastic food containers. The diagram in figure 10.2 shows the structure of polypropylene. Figure 10.2. Some waste polypropylene plastic is disposed by burning. This makes a toxic gas because of incomplete combustion. Name this toxic gas. Very easy, it must be carbon monoxide. Carbon monoxide. Number 2. State one other environmental challenge caused by the disposal of waste polypropylene plastic. Explain how this challenge is related to the properties of polypropylene. Environmental challenge and explanation for this. You can have accumulation of plastic in ocean. Accumulations of plastics in ocean. Or landfill. Now, explanation for this, that they do not dissolve in water or chemically unreactive. Chemically unreactive or do not dissolve in water. C. Name one condensation polymer. Draw the displayed formula of the linkage between the repeat units in this polymer. You have to name any condensation polymer, like you have nylon or polyester. Nylon can also be known as polyamide. Nylon or polyamide. And you can write polyester or PET. For polyamide, show the linkage. This must be the linkage for polyamide. And single bond H, single bond C, double bond O, single bond. What about polyesters? Polyester must contain single bond C, double bond O, single bond O, single bond. This must be the linkage found in polyester. Now that's all for this video. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.